OK，嗨，OK，今天呢，现在呢，我们就会学第三个 subtopic of the chapter 7，就是 what we call as the Einstein's photoelectric theory. So 这个 Einstein photoelectric theory 呢是continuous of the photoelectric effect. 在上一个 subtopic 我们知道 what is the photoelectric effect 的 is a process of the is a process where the metal is being illuminated by a beam of light with certain frequency. Okay, electrons is able to be emitted from it. Okay, so 这个就是 photoelectric effect. Okay, so note that 就是说我们知道讲说那个 metal 一定要有 certain frequency， 它of the light， 就是说它有 certain 的 photon energy，OK， or received by the light. Okay, hit the threshold frequency of the metal, then the electrons only able to be escape out through the process what we call as a photoelectric effect. Okay, so from the previous subtopic 7.1的时候，我们知道讲说radiation 还是 light 也好 ，electrons 也好，它有这个 what we call as a wave particle duality， 就是说它可以是 wave， 它也可以是就是light particles。OK， so from that 我们知道这个 photon energy E equals to HF。OK， is explaining the relationship between the particle property and the wave property. Okay, so it is called the Einstein photoelectric theory and applies to all electromagnetic waves. Okay, so for example, like radio waves, microwaves, visible light 都 apply 这个 Einstein photoelectric theory 的。Okay, so 我们要知道讲说这个 photons that applies 这个 Einstein photoelectric theory 呢，它是一个 packet of energy with discrete wavelength. Okay, discrete wavelength 的啦。Okay, so when a photon arrives at the metal surface, the photon energy is fully absorbed by the electron in the metal. Okay, extra energy will become the kinetic energy of the photoelectrons. OK， 在这边发生什么事情呢？就是OK， 我们可以把这个当成是一个 metal surface。Okay, so 它是 irradiated by the light. Okay, and 这个 light 呢，就是会 transfer 这个 photon energy to the metal. Okay, so 这个 photon energy 呢，我们知道讲说是 E is equals to HF. Okay, then 我们也知道这个 metal, okay, 它有 what we call as the threshold frequency. OK， 当你这个 photon energy that is received by 这个 metal surface， 它的 frequency， 这个 photon energy 的 frequency is greater or exceed OK the before that 我们要讲这个 photon energy is fully absorbed by the metal surface, the electrons in the metal surface. OK, the electrons in the metal 啦。OK。Okay, 当这个 photon energy 的 frequency is greater than the threshold frequency of the or is hit, okay, exceed the threshold frequency of the metal, okay, 它就会 able to escape out from the metal surface. So that escape out from the metal surface is using the kinetic energy. So which means that 这个 photon energy, okay, 它是 equivalent to the energy, okay, that's based on the energy required by the electrons in the metal surface, okay, where it exceeds the threshold frequency, and 当它已经 exceed 了 escape out from the metal surface already， 它就是用这个 photon energy 剩下的 photon energy act as a kinetic energy to be moving out, okay, move out, okay, moving 啦， yeah, 这个就是那个意思。所以呢 based on what do we call as the principle of conservation of energy, okay, energy cannot be increased or cannot be increased or decreased， 就是说 cannot be destroyed 啦， it only can change from one form to another form, okay， 所以呢 that's why 这一边我们就可以用这个 photon energy OK， 这 photon energy is the minimum energy required to release the photoelectron based on what we call as the threshold frequency 啦。OK， threshold frequency。OK， then 还有就是加 maximum energy of the photoelectron。所以我打个比方，如果这个是一个 metal，OK， 这个 is illuminated by the light。OK， 它的那个 light 的 photon energy 是 maybe 5 joule。OK， 5 joule。So 它这个里面的 electron， 它一定要 exceed 那个receive 就会 receive 这个 photon energy 5 joule of photon energy。So 可是这个5 joule of photon energy 它一定要 exceed the threshold frequency of the metal. For example, maybe based on 这个 threshold frequency 的那个 minimum energy maybe 2 joule。So 这个2 joule 就是 coming from 5 joule of it。OK， the one part of the 5 joule 啦。Then 剩下呢 ，OK， 当它 receive 这个2 joule based on 这个 threshold frequency， 它就 able to escape out from the metal surface。OK， through the process what we call as the photoelectric effect。So 当它是 escape out as the photoelectrons 的时候，它就会 move with the maximum kinetic energy。So 这个 maximum kinetic energy 就是3 joule。所以呢 that's why 你看5 joule 它会 being converted into the minimum energy required to release the photoelectron and the maximum kinetic energy for an photoelectron。所以你就会看到这一个东西 E is equals to W K max。这个 W 呢，就是 what we call as the work function。So in other words， 这一个如果 based on 我画的这个 diagram 的话，这个2 joule，OK， 这个2 joule 就是我们的 work function。Then K max 呢 ，maximum kinetic energy 就是我们的3 joule。So 我们知道讲说这个 photon energy is the based on the frequency of the light， 所以就是有这个 HF。OK， 这个 HF。OK， 等下你就会看到 W 呢有 equals to HFO 的。OK， 为什么呢？因为这个 W 是 based on the what we call the threshold frequency of the metal。OK， 当它是 threshold frequency 的时候呢 ，the photon electrons are emitted without any kinetic energy。所以就说 the kinetic energy is equals to 0。So W 就会 equals to HFO。OK，HFO。OK， 所以如果你 substitute 进去的话 half mv square is equals to hf minus W is equals to HFO， 所以你就会达到最后这样的一个 formula。OK，but as long as 你知道 as long as 你知道 E for the photon energy is equals to W plus K max。Then 你这个 W 是 based on the threshold frequency, the work done for the electron to exceed the threshold frequency of the metal， 所以呢我们就是有这个HFO， 这个是 half mv square。For kinetic energy 都是 half mv square 的。OK。So at threshold frequency 就是说呢what do you call it？ 当它是 threshold frequency 的时候 the light is at a threshold frequency 的时候，那个 light 就会 be escape out as the through the photoelectric effect， 所以它就会直接 escape out， 没有那个 without any kinetic energy already。OK， so next， OK， so 我们的 energy 这边呢，刚才我们全部讲的那个 photon energy is being what they call measured or calculated in a unit of joule。其实 energy photon and especially photon energy 啦 can be calculated using the unit what we call as electron volt. Okay, electron volt. Okay, so electron volt. Okay， 我们如果 if an electron has a charge of magnitude of 1.6 okay coulomb that travels through a potential difference， so 你的那个work done is QV， 因为我们知道 V is equals to E over Q。Okay， the amount of charge to move from one point to another point. Okay, the energy needed to move a charge from one point to another point， 这个就是那个 potential differences 的那个 definition。所以呢，我们就是 V equals to E over Q, then E is equals to QV. So 1 electron volt, 1 EV 啦，is the energy transferred when an electron travels through a potential difference of an E volt. So 1 EV is equals to 1.6， 所以呢，如果 to convert into EV， 你只是乘 1.6。如果你要 Joule 变成 EV， 就是 divide by 1.6 times 10 to the power negative 19。OK，so 刚才我们看到那个 Planck's constant 里面，我们知道讲说它是用 different color of light。So 其实呢，为什么它要用 LED？ 因为 LED 呢是 LED stands for light emitting diodes。我们知道 diodes only allow the current to flow in one direction, okay, forward direction. So 而且因为它是 semiconductor， 它需要一个 minimum voltage, okay， 这个在这边我们就叫做 activation voltage to apply in this direction before it allows a current. So this make 就造成了每一个 LED different color 它就需要 different the threshold voltage for the current to flow and emit the light. So different color of light 就有 different 的那个 threshold voltage. 所以呢 low light LED 好像 low light wavelength 的啦 for example LED red LED 它是 low energy, it requires low activation voltage. 就是说 different light color of light requires different activation voltage. Okay, then blue 的呢就是说它好像 higher frequency 的啦 it has higher activation voltage to make it conduct. Okay, so 这个就是 the relationship between the work function and the threshold frequency. 我们知道在这一个我们有看到这个 graph 是 based on Kmax 跟 frequency. So 我们的 frequency increase 当它 reach 到一个 FO 就是 threshold frequency 你的 photoelectric effect 就会 occur. OK， 你看之前这边是没有 Kmax 的，到了它 exceed the threshold frequency 的时候，它的 Kmax 才会 increase. Okay, so work function is the minimum energy required for the photoelectron to be emitted out from the metal surface. Based on what? Based on the threshold frequency. Okay, it's the minimum energy for the light photon to produce the photoelectric effect. Okay, so how to find the FO? It will be the intercept of the, this is intercept, intercept on the frequency axis. Okay. So different metal 有 different the threshold frequency. Okay, higher threshold frequency, which means that 它需要更加多的 energy. Okay, which means that 它 higher work function. Okay, 更加需要多的 energy for the photoelectric effect to occur. Okay, so 我们就会有这个what do we call experiment， 就是说等一下我会给你看下一个 video， 就是关系到这个 experiment 的，它是用不一样的 light， 因为我们知道不一样的 light 会有不一样的 frequency。OK， 你看哪一个 light 有 hit 到 the threshold frequency of the certain metal, photoelectric effect 就会 occur。OK， 所以我给你看这个 video， 所以它有3个不一样的变化，你看啊。它有变化 on the intensity, okay, sorry, the light frequency, okay, the different types of metal 跟就是 bright 跟 dim, okay, 我们就要看说哪一个 factors that will affect the work function and also the what they call 这个 work function for the photoelectric effect to occur. Okay, let's see here.
I just want to show you around this photoelectric effect animation. It really is pretty simple. There are just two controls. There's the slider that controls the frequency of the source. This is the metal, and you can see no electrons are coming off the metal, and that means we are below the threshold frequency for this metal. The metal is calcium. Actually, there are 3 buttons. There's the choice of the metal, there's the slider that controls the frequency of the source, and then there's the bright and dim button. So the way it works, and what you'll be asked to do, is to find the frequency, the threshold frequency. For each metal, let's find the one for calcium, because right now we're on calcium, and the frequency is shown here. So I'll slide it, and you can see that at these frequencies, there's no photoelectron emission. None still, none still. We go to green and then violet, and we don't get an emission. And all the way at the end of violet, right about here, we get an emission. So if you
So
ask for the
different
threshold
frequency of the
frequency,
light
the
will
calcium,
affect
it's
down
about
the photoelectric effect to
7.07
occur.
times 10 to the 14th. So
So
that's what you're going to have to do for each metal, find the threshold frequency, and that's about it, actually. You'll see that if you change the
7.07就是
light
the
to
threshold frequency
bright,
of the
you
calcium.
get more photons and more photoelectron emission. But once you're under the threshold frequency, and this is the key takeaway in the photoelectric effect, if you're below the threshold frequency, what they would do is they were wondering, why is it that when you're below the threshold frequency for a metal, in this case 6.82 times 10 to the 14th, even if you make the light brighter and brighter and brighter and brighter, what they could not understand before Einstein explained it is that if you made the light brighter and brighter and brighter, why is it that it was not sufficient energy to get emission? So
So
that's
it shows
this
that
is the
intensity
lab.
of the
I
light
don't
does
think this
not
lab is going
affect
to
the
work on an iPad,
photoelectric
but I
effect.
could be wrong. I don't think the sliders will work on an iPad, so you'll have to go to a PC for this. So here's how you choose a metal. There's cesium. And you can see
Different
calcium.
metal 就有
Let's try
different
to.
的
Yeah,
那个
calcium
threshold
doesn't emit at
frequency.
this frequency, but cesium does. One of the big takeaways on this experiment too is that if a metal held its electrons very tightly with a lot of energy, it would take a high threshold frequency to get emission. And remember that the
So
photon
higher
energy is
threshold
proportional to
frequency,
the
which means
frequency.
that
So if
你
I
的那个
double the
electron 在
frequency, I'm
metal
going to
里面
double
是
the
being
energy.
grabbed
That
more
is it.
tightly， 所以它需要更加多的 work function to escape out。所以 higher threshold frequency, higher work function. OK， so 就是这一
I just
边。
want to
OK， so 这一个 里面的这些 calculation 你们可以自己再看，然后有什么不明白的你们可以再问我啦。OK， 有一些examples 在这边啦。OK， so 在这边呢，有时候他会叫你identify the answer in EV， 可是你不用慌，你 as long as 你跟着 normal 的那个 procedure 走的话，就会找到答案了的。OK， so generating photoelectric current 就是 photo current in a photo cell circuit， 这个就是 photo cell circuit。我们有那个 emitter 就是 cathode 跟 anode 就是 collector。为什么 collect？ 它 collect the electrons。OK，then 里面是一个 vacuum。OK，so cathode 是 coated with a light sensitive metal。OK， 你 connected to the negative terminal. Anode is connected to the positive terminal. So photoelectric current is produced in the circuit when the photo cell is illuminated by light. Different metal have different FO, okay, different work function, okay, 这个刚才我们讲到了的。所以你看 cesium 跟 lithium, okay, 你会发现到 lithium 它需要更加多的energy for the photoelectrons to escape out from the metal surface. 所以你看 the threshold frequency between cesium and lithium 是比较高一点的 ，OK？ 所以你看它的 frequency 越高，它的那个 wavelength 越低，因为我们知道 the higher the wavelength, the higher the frequency, the shorter the wavelength。它们两个的那个 relationship 是 inversely proportional 的 ，OK？ 看啊。Okay， 最后一个 as the light intensity increase, the photoelectric current also increase。 为什么呢？因为你不要忘记，它只是 increase the number of electrons to be escape out from the metal surface 吧，因为就是它 increase 那个越多的 electrons 可以 receive enough threshold， 就是 certain light 的那个threshold frequency 啦。OK，so for example， 好像说 OK。你的 light， OK，for example，sorry 啊，我来写这边啊。OK，for example， 你的这一个 light， 我画一下，这边的意思啦，我要 focus on 这个最后一个啦，最后一个这边啊。OK， 如果说这个 cesium 我们知道它的 threshold frequency 是 5.16 Hz，OK， 有一个 light。真正就是差不多 5.2 times 10 to the power 14的那个frequency， 这样它已经是 greater than 这个 threshold frequency 了的。What happened? Electrons is able to escape out through the photoelectric effect。 可是如果你这个 5.2 的 light intensity 是比较高的话 ，OK， 比较高的话，你就会 able to produce more electrons from it， OK， 因为更加你的亮了嘛，你越亮了，越多 electrons is able to receive the enough work function， OK， to escape from the metal surface。 So 你越多 electrons， 你的 photoelectric current 就是 photocurrent 啊 ，photoelectric current 啊，就会更加的提高。OK， 它这边的是这个意思。However， 记得 photoelectric effect does not depend on the intensity, but is depending on the frequency of the light. OK， 那这个是 video 关系到 photoelectric cell。
Photoelectric cell. A photocell is a technological application of the photoelectric effect. It is a device whose electrical properties are affected by light. It is also sometimes called an electric eye. A photocell consists of a semi-cylindrical photosensitive metal plate, C, emitter, and a wire loop, A, collector, supported in an evacuated glass or quartz bulb. It is connected to the external circuit, having a high-tension battery B and microammeter. Sometimes instead of the plate C, a thin layer of photosensitive material is pasted on the inside of the bulb. A part of the bulb is left clean for the light to enter it. When light of suitable wavelength falls on the emitter C, photoelectrons are emitted. These photoelectrons are drawn to the collector A. Photocurrent of the order of a few microampere
So
can
一
be
个是
normally
emitter， 一
obtained
个是
from a
collector，collector
photocell.
就是 anode，
A
emitter 就
photocell
是 cathode。
converts a change in intensity of illumination into a change in photocurrent. This current can be used to operate control systems and in light measuring devices. A photocell of lead sulfide, sensitive to infrared radiation, is used in electronic ignition circuits. In scientific work, photocells are used whenever it is necessary to measure the intensity of light. Light meters in photographic cameras make use of photocells to measure the intensity of incident light. The photocells inserted in the door light electric circuit are used as automatic door opener. A person approaching a doorway may interrupt a light beam, which is incident on a photocell. The abrupt change in photocurrent may be used to start a motor, which opens the door or rings an alarm. They are used in the control of a counting device which records every interruption of the light beam caused by a person or object passing across the beam. So, photocells help count the persons entering an auditorium, provided they enter the hall one by one. They are used for detection of traffic law defaulters. An alarm may be sounded whenever a beam of invisible radiation is intercepted. In burglar alarm, invisible ultraviolet light is continuously made to fall on a photocell installed at the doorway. A person entering the door interrupts the beam falling on the photocell. The abrupt change in photocurrent is used to start an electric bell ringing. In fire alarm, a number of photocells are installed at suitable places in a building. In the event of breaking out of fire, light radiations fall upon the photocell. This completes the electric circuit through an electric bell or a siren, which starts operating as a warning signal. Photocells are used in the reproduction of sound in motion pictures and in the television camera for scanning and telecasting scenes. They are used in industries for detecting minor flaws or holes in metal sheets.
Okay, so photoelectric effect 有很多的那个 function application. So one of the example 就是 solar cell. Okay, during daytimes, photoelectric effect of the solar cell enables the electrical energy to be stored in the battery. Okay, 因为我们知道 electron is being escaped out from the metal 嘛， so 它就会 converted into electrical energy. So 在这边it is energy efficient and environmental friendly. OK， 不止这样，它也是 as a light detector of the automatic doors。OK， 所以 in between 你看这一边中间这一边有一个 detector， 这 detector 就是 always being illuminated by the light。OK，however， 当有一个人 pass by 的话，它就是 block the pathway of the radiation already， 所以你的 photocell 就会 be interrupted 了，然后它就会使那个 motor to start function， then 那个门就会这样打开 already。OK， so 你看 when the light path is disturbed, photoelectric current will be disconnected and the door will remain open. OK， 还有最后一个也是用在我们的 image sensor used in the high resolution cameras. OK, so with this 我们就已经做完整个 Chapter 7 already. OK, Chapter 7会比较重要的就是在7.2跟7.3。OK， 所以呢，如果你们有什么东西不明白，关系到 photoelectric effect 的话 ，OK， 你们就是可以either就是看我的 slides 多一点，还是就是做多一点练习啦。OK， 有什么不明白可以继续问我。OK， 所以谢谢大家，拜。